Hello everyone, myself Ajit, and today's topic we are going to discuss is some telecom transmission parameters and performance criteria. In this session we are going to discuss transmission parameters like jitter, wander, drift and performance criteria. One by one we will discuss these parameters. First one is jitter. To understand jitter, let's look at this figure first. This solid line signal is idle clock and dashed line signal is jitter clock. We can see the rising edges of jitter clock have a displacement from the idle clock. This phenomenon of timing displacement from its idle position is called jitter. Let us discuss the definition of jitter. The jitter is defined as short-term variation of a digital signal from their reference position in time. Let us discuss why jitter is bad for communication system. To understand why jitter is bad for communication system, again refer the diagram. From the diagram we can see that jitter causes the decision point to move away from the optimized position. This results in bit errors and degrade the performance of transmission system. Just now we discussed first transmission parameter jitter. Secondly, we also have a transmission parameter which is known as wander. Let's discuss next variation, that is wander. The term wander is defined as long-term variations of a digital signal from their reference position in time. This means in wander, decision points move away from optimized position, and that too for long duration than jitter. According to ITUT, jitter frequency below 10 Hz is called wander and more than or equal to 10 Hz is called jitter. The jitter is the short-term variation, whereas wander variation occurs over a period greater than 1 second. Wander brings problem in a chain sequence of events. It causes pointer adjustments and slips, that is delays. The main cause of wander are changes in temperature and clock performance. Let's move ahead understanding some more transmission parameters. The next parameter we are going to talk is drift. We discussed about jitter and wander, whereas drift is comparatively long-term change in an attribute or a value of system parameter. Drift is undesirable and unidirectional, but may be bidirectional, cyclic or long-term duration transmission parameter. From this we may say that jitter, wander and drift have increasing periods of variation. Means we have to control the small time errors for long-term benefits of the system. What we conclude here is, along with taking care of transmission parameters like attenuation, bit error rate, signal to noise ratio, etc., we should also take care of other variations, that is jitter, wander and drift. And to calculate these parameters, the device which is commonly used is known as DTA, that is Digital Transmission Analyzer. That means DTA is used for measurement of both bit error rate and jitter. Till now we discuss about transmission parameters. After transmission parameters, we will talk about some performance criteria for digital transmission. As we discussed earlier in transmission unit session, bit error rate accepted value is 1 in 10 to the power 6. That means only one error is accepted in 1 billion bits, which is considered to be better performance. Similarly, if 1 bit error in 10 to the power 5 bits is considered to be good performance, and if 1 bit error in 10 to the power 4 bits is reasonably accepted performance. if we have 1 bit error in 10 to the power 3 bits is just acceptable performance, and error occurs more than 1 bit error in 10 to the power 3 bits is not at all acceptable in telecom. Therefore, we use digital transmission analyzer, which provides level of bit error rate of telecom equipments. Hence, it is essential to have a device with minimum amount of bit error rate, so the good quality of service can be maintained. This shows bit error rate greatly affects on data channel and data services. Hence, we accept that bit error rate should be 1 in 10 to the power 9. Let's take one example of subscriber network. Let's say that the performance at CO, that is central office, is 1 in 10 to the power 6. Now, if information or signal moves with this performance towards cabinets and pillars, performance may reduces to 1 in 10 to the power 5 due to different types of losses. If information or signal moves with this performance, that is 1 in 10 to the power 5 towards distribution point, performance may reduces to 1 in 10 to the power 4 due to different types of losses. Now, if it continues towards CPE, that is customer premise equipment, performance may further reduces to 1 in 10 to the power 3 due to different types of losses, which is just acceptable performance. Means, in this situation, customer receives acceptable quality. Now let's take another situation. Let's say that the performance at CO, that is central office, is reduced, that is 1 in 10 to the power 5. Now, if information or signal moves with this performance towards cabinets and pillars, performance may reduces to 1 in 10 to the power 4 due to different types of losses. If information or signal moves with this performance, that is 1 in 10 to the power 4 towards a distribution point, performance may reduces to 1 in 10 to the power 3. Now, if it continues towards CPE, performance may further reduces to 1 in 10 to the power 2, which is not at all acceptable. Means, customer does not receive good quality of service or good performance. Hence, to measure the quality of transmission system, these performance criteria play important role. So, let us review telecom transmission parameters and performance criteria we discussed till now. First was jitter, which is the short-term variations of a digital signal from their reference position in time. Next is wander, which is long-term variations of a digital signal from their reference position in time. Third is drift, and last we discussed different performance criteria.